Hello, 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 everyone. How's it going? Uh, I was going to say long time no see, but we actually saw us each other uh, an hour back. So yeah, welcome back to folks who are coming back, and hello everyone who's coming for the first time. What are we doing? We are learning a bit about machine learning using JavaScript, even though till now we haven't done any machine learning coding in JavaScript, fortunately, but we have built a very nice application which, if you upload an image, it actually reads the image and it reads what's written in that image and shows us the output. Example, if I click on run button here, wait for it to like kind of load. I can click on this, open in new tab, choose file 1.png, and hello from GHW. Okay, that was the extracted text. Okay, but at the same time, if we give it like 2.png, which has hello from GHW written, it does not recognize the M. Okay, so that is a problem. And if I give it this particular bit of text, which is big, like tensorflow.js is a JavaScript library, blah blah blah, it definitely fails at that. Okay, so that is what we have done till now. And well, for the time being, I will wait for folks to join, and then yeah, we can go from here there. Uh, Hello, everyone. Whoever is saying hello in the chat, thank you so much for joining back. Anybody have notes of the last session? No notes as such, but what I can share with you is the code that we have written till now. Okay, so please do have a look at the code, and you can also actually check out the session. Okay, so if I go over to YouTube and I search for Major League Hacking, I can share the link to part 1. And yeah, the slides. Yeah, I had forgotten about the slides. Uh, yep, that's it. So you have the code, you have the slides, and you also have the link to the part 1, which is on YouTube. The part 2 is currently live on YouTube, so you can actually check it out from there. Okay, so yep. Well, that's kind of enough introduction, I feel, right now. And now let's move on to the next part. Okay, so the next part, as you saw that right now, it's like definitely not reading this big piece of code, this big piece of text, but specifically this, can we improve this part? Okay, and if we have to improve it, how do we improve it is what we are going to look at right now. How do we add some functionalities? And in this piece of code, we will also kind of check out how TensorFlow JS works in the browser, or what are the functions that are available in TensorFlow JS for the browser itself. Okay, so that's what we are going to do. And let me remove myself from the screen so you can solely focus on screen. I also don't like the way this kind of is looks like. So we can also do some styling bits here. Okay, we can style this whole thing, but we'll do that later. Okay, it's not a necessity right now. Okay, so moving on. Let's create should we style it like right now? Actually, let's style it right now a bit, very tiny, teeny tiny bit, uh, just so that when we add more components, which we are going to, it does not cause problems, or like then we have to come back and style, which is a pain. So let's style it a teeny tiny bit. So step one, where are we going to style first? We are going to go over to app.jsx, and we have a main there, right? Which is nice. And we have this OCR reader. So since this is my V1 OCR reader in a way, I am going to wrap it inside a div tag. So I'm going to, and let's say format this. So I have wrapped the OCR reader inside a div tag. Now I'm going to style this div tag, and I'm going to tell it that the width is going to be 100%. Okay, I'm doing inline styling. I'm not bothering with going over to CSS files and styling it and stuff. And what is this? So we are actually going to create a line between the top text and this OCR reader one. So the height of the line would be like, let's say 5 pixels. The color of the line will be let's say black, and then the padding. Okay, the padding around the line would be like, let's say 2 pixels. The margin around the line would be like 2 pixels, and the background color would be, let's say, black again. And now let me format this. So as you can see, I've written this style equals to like 2 curly brackets in the div tag. Okay, so now if I go here and reload this whole thing, okay, there we go, perfect. So there's a title at the top, but this chosen file and no file, choose file and no file chosen and stuff, it's kind of overlapping. So let's also fix that. But you saw what we created. We created this black line because we are going to divide our sections. We are going to create a OCR reader V2, and probably if we have time, we'll also create a V3, so that all three implementations remain with you. Okay, so that is why we are going to divide the sections. Let's go over to OCR reader.jsx, and let's kind of style this as well. So we'll go to this first div tag in the return, and inside this we will go style equals to double curly brackets. We will say the text align should be center, the max width. Okay, we can give it a max width. It should be like, let's say 900 pixels, and the margin should be auto. Okay, formatting this. If we go there, now you can see this whole thing is kind of center aligned, right? uh, what else? The image is fine, I feel. We don't need to add a styling to the image upload component that we created. Inside the image, we again have a div tag, so we can kind of style that as well. So style equals to, we will say overflow is auto, and the max height of the image should be 80% of viewport height. What is a viewport? The viewport is this full thing. Okay, so we are saying that the max height should be the should be 80% of the viewport height. Okay, then that is good. The div here, we can kind of add a style here to say that from the margin top. Okay, the text needs to be like 20 pixel down. Okay, so space between the margin top and this should be 20 pixels. uh, Yeah, should have added the 20 pixels here. So in this particular div, we are going to add the top margin. So the way margin works is you have you have the top, then you have the right. So from right, let's say 10 pixels, then you have the top right bottom, and then you have the left margin. Okay. So, and if you do a shorthand, the way I'm doing it, 20 pixels and auto, this applies to top and bottom. This applies to left and right. Okay, so something like this is what we end up with. So now if I go there and choose a file, it's kind of within this bounding box, not going beyond this whole thing. And that's where we can see the text. Also, I don't think I like the H1. I'm going to go back to P and also close it with p tag. Okay, so if you change it on the opening, also of course you have to change it at the closing, and this is what we end up with. Perfect. uh, Anything else that we can add which is necessary? I don't think so. I wonder, I don't think I really need this. Let me see. If I reload this whole thing, choose file, uh, 1.png, yeah, not really needed. Perfect. And of course you can style the text and stuff, so you can change the color of the text if you want, but not, again, not really needed. uh, this much is good enough because we are going to create the part 2. Maybe again, if the time permits, we can also style the input box to look much better, the way, like, compared to the way it looks like right now. You can also, of course, add some styling to this thing, like to this particular div if required, and the input if required. So like example, let's say I can add a style where I go like the padding is like 10 pixels. uh what else? The background color is like, you can add some color if you remember, like any hash color, or you can also add things like, let's say, aqua. Okay, that's a named color that you can add. Hmm, I wonder why it's not applying on the button. I'll have to check. But okay, I think that's good enough for now. Okay, so any questions? Okay, how can you gain points? I think it depends on uh this, right? The registration of the session. So if you haven't already, please register for the session here. Okay, so please register for the session. And then there's a question, not this one. So actually I'm working on the same REPL. It gets uploaded, sorry, it gets updated automatically, or automagically, as I sometimes call it. So like, let's say if I go into incognito right now, uh, it is the same REPL. Okay, so the one shared by Steel Blue, yep, that's the same one. uh, and whatever code that I had written, example, the style, uh, and styling the OCR reader, all of that is now reflected. Maybe refresh it like twice or thrice, because like right now, I'm looking at it in incognito, which basically means that it does not really know what changes have I made. So maybe refresh it twice or thrice, or maybe like clear the cache and reload. Uh, you can like kind of do control shift R or command shift R to hard refresh. uh, Or there's also a very nice thing where you can kind of do inspect. Okay, now right click on the reload button and you can do empty cache and hard reload. Okay, it clears away any cache that is there and it should probably fetch the new one. Okay, so you can do something like that. And yeah, so we have done some styling, which is not much. Also need to see why the choose file is not being styled. I'll think about it. But other than that, uh, yeah, we have added this and center aligned bunch of stuff. Now let's go to the next bit, which is let's create a OCR reader v2.jsx. Okay, so I'm going to create a new file in the source folder. Okay, so in on the source folder, you click on it, click on this kebab menu and click on add file. You do OCR reader v2.jsx. Okay, try to create. Okay, cannot hear my voice. Am I audible right now? Hello, hello. Mic test, test mic, something, someone. Audible, perfect. Okay, perfect. Thank you so much, folks. Uh, there's also another question. Will the videos be uploaded anywhere? It's on the YouTube channel of Major League Hacking, so you can find it there. I had just searched for it. Wait, let me check. Yep, there it is. So you can find the part one here. You can find the part two in the same channel. So in the same channel, if you go to the live session, uh, that's where whatever we are doing like right now, uh, it's like live. Okay, and I have no idea what I copied. I want to copy the video URL and paste it there. Okay, so you have the video URL of part one and you have the video URL of part two. Okay, so part two is currently live. And yeah, moving on. So OCR reader v2.jsx, try and create the file name to be exactly same as mine so that, you know, if you miss out on some piece of code, you know where to write it and what, and yeah, bunch of other stuff. I'm going to close this part and I am now going to create a new component called as OCR reader v2.jsx. So you know the drill. You do import react from react and then you do a const OCR reader v2 equals to no inputs and something like this, and finally you do export default. Okay, there's another question. Can I run it on local machine? Yes, you can. All you need is Node.js. You need any text editor, could be like VS Code or something, and that's it. And of course, the libraries that you are using. So we actually installed a library when we had gone on, like just before we went on the break, which was this tesseract.js. Okay, so you would need to install that particular library. Let me share it in the chat again. So you'll need to install this particular library, and yeah, I think that should be good enough to get started and complete the v1. Okay, so OCR reader.jsx should start working fine once you install this. uh, okay, so as I said, we all know the drill. So we created a component and inside this we can write a return, and I can say a div tag, and this is we can say hello from OCR reader v2. Okay, I'm going to format this uh, can also wrap it around a h1 tag format. Okay, and now uh, we have to go to our app.jsx, and you remember this OCR reader which was wrapped around the div tag. I'm going to copy everything from line 8, which is where the div tag starts, till line 19 where the div tag ends. So I'm going to copy that and I'm going to paste it right below. I'm going to change two things. The color black, I'm going to change that to blue. Okay, so that's the first change I'm doing. And for the OCR reader, instead of having it as OCR reader, I am going to actually import the OCR reader v2. So if you just write v2, it will prompt you to import it from the same file. So that's OCR reader v2. If I go here, if I reload, okay, this is because of the h2 tag, but I only see like one import. Oh, because well, we have not made any changes in the OCR reader v2. It's very simple right now, but yeah, you can see the hello from OCR reader v2, right? Okay, so you now know what the color does. Okay, it's coloring up that particular part. Now inside OCR reader v2, this is where all the magic, the second part of the magic is going to happen. So let's start writing there. What are we going to do? Well, we are going to use Tesseract.js again. Okay, so we are kind of recreating what OCR reader did. Okay, OCR reader.jsx, whatever we did there, we are going to kind of do exactly the same things in v2. Actually, let me rename the OCR reader as OCR reader v1. So it's easy to call it, right? Uh, so OCR reader v1.jsx, and I'm also going to change it inside here. So the function name would become v1. We are also going to export v1, and comment would be v1. v2 is fine. We go over to app.jsx, and here now we are going to import v1 from v1, and this component on line 19 would become v1. Okay, so now it's very easy to say. We have OCR reader v1. Okay, let me like reload this whole thing. Uh, if you don't want to see v2 for the timing, you can just comment it, and that will be removed. And v1 still should work the way it was working previously. Okay, yes, it does. Perfect. So all I did was rename the OCR reader.jsx to OCR reader v1.jsx. And then we also created OCR reader v2.jsx. We are going to code inside that. And yeah, as I was talking about, so we are going to do exactly the same thing as v1 in v2, just add a bit more functionality. So let's first copy over the things that already existed. Example, import image upload from dot slash image upload. Okay, image upload was a component which we created, which basically takes in the image. And then inside the v2, we'll create the the use state things that we had created. So const image comma set image equals to use state null. We also had a const text comma set text. Now some of you might be like, well, why don't we copy paste it exactly? Well, that's a good idea, but at the same time it's also a bad idea, because writing it down kind of puts it in your memory. Okay, so I know that we have to use these use state variables because, well, uh, that's what will help me retain the value of the variable. Then we also would add a const handle image change function, which takes in the image data. And in the image data, we basically do the set image, which sets the image data. Okay, this particular set image, which changes the value of this variable. And then we do a process image. We had created this function. Okay, if you remember, we had created this function in v1. We are recreating it, and inside the const process image, what were we doing? So I'm going to just write this. uh yeah, what were we doing? If you remember, we were just doing some tesseract things, right? So this, we are going to go like, it takes a image data, and then we were doing something from tesseract, which we have to import from tesseract.js, right? When will it start? What do you mean? We are live, right? Okay, as per me, yes. Wow, that was a mini heart attack. I was like, wait, what? Are we not live? Okay, tesseract.recognize. Uh, and then we were passing the image data, also adding the language, like everything is written in English. So that, and then we were also doing some logger stuff where we were like kind of printing out the logs in the console. So console.log of m, not really required. So you, if you want to avoid it, you can, frankly. Uh, and then we're doing this whole dot then, and in that we were then adding this again, which has a data, and that has a text on it, and then we were returning or setting the text, if I remember. Yeah, perfect. And then format this whole thing, and this is v2. Instead of using h1, I'm going to use a p tag there. And what else? We can style it, right? So we can go like, oh, the text align should be, hello, sorry, uh lost my net in between. Am I audible? Okay, perfect. Sorry, yeah, lost my net in between. Okay, going back. uh yeah, we can kind of style it here. So text align, let's say, I'll say, yeah, it needs to be in center. uh I think that should be good enough. And then we can use the image upload part, the image upload component, where on image change, that was a variable or a property that we were handling down, and that uses, that will get this function that we created at the handle image change. So that's good. And then we were doing something like image and inside this image, what were we doing? Wait, let me go back. We were using a div tag which has an image. Uh, okay, let's let's write it, because I was going to copy paste it and then I was like, wait, didn't I already say that let's not? uh, so style, we can style it. Let's say the max height should be like 80 viewport height, and that should be good enough. And inside this, we are going to use the img tag, where the source would be exactly the image. Okay, and the style is going to be max width is, let's say, 100%, and the max height is also like 100%. And we need to close this image tag, so we can do this like right here. Let's format this whole thing. So this is how it looks: the div tag, the image tag, source, style, the div tag closed, which was open at like 27, closing at 35. And yeah, then we were showing the extracted text, right? So div style equals to, like, from margin top, we can go like 20 pixels. Okay, closing the div tag, and inside this we will go like h3 and extracted text. What is that, and what is the extracted text? Let's paste that. So that would come from this text variable. Okay, I think that's good enough. If I go over here, I reload this. Okay, there is some sort of overlap. Don't need this, and there's still an overlap. Can put margin auto. Hmm. I guess so. That should be it. Good enough. Nope. Still overlap. What else? Uh, Actually, from the margin top, I think it has something to do with my this one. Wonder where am I going wrong? Because okay, I think I kind of understand why. This div tag that I'm creating, it should not enclose the OCR reader v1. It should be self-closing. So we don't actually need this. And yep, that's good enough. Perfect. Yeah, don't need to do this, and this could be a margin. Okay, perfect. Okay, so a quick change, app.jsx. If you remember that div tag that we created, we were actually wrapping it around the OCR reader v1. So it started here and it was closing here, but that's not the case. The div tag is self-closing. Okay, so you see this change in line 18. That's what I did. And similarly on line 29, I did that change. So now we have kind of division between the v1 and v2. So if I go over to v2 now and I add a p tag saying OCR reader v2, this is where it starts. And similarly, if I copy this over, go to this OCR reader v1, and okay, so that's our v1, this is our v2. Okay, good, enough to understand. Okay, perfect. So what have we done till now? We have kind of made some styling changes in app.jsx, and we have created this OCR reader v2.jsx, which is exactly same as OCR reader v1.jsx. Okay, and I am now going to wait for a couple of minutes, let people like catch up. Copy paste the code if you have to, but yeah, please like reach this point. And once you're done, let me know. Also, I think I had said this earlier. From index.html, I'm going to remove this particular script because that's what writes the run on replit. Okay, so that has been removed now. Okay, I think everyone would have reached till this point by now. So yeah, I'm going to move ahead from here. So OCR reader dot v2.jsx. Okay, what are we going to use? So we are going to introduce TensorFlow.js now. Okay, and this is going to be interesting because we are going to use the TensorFlow.js to kind of make changes to our image. Okay, uh, what kind of changes? So if you remember, and like I'm pretty sure you do, if you go over to the v2, upload the 2.png, it reads this and it gives us a output, and it's missing the m in the from. Okay, so let's try and see if we can do something about it. The best way to make changes in the, like, if you have to read from an image, if you have to read text from an image, you have to make certain changes in the image itself. What sort of changes can you make? Number one, the good thing would be, like, one of the things that you should do is to remove the noise. Now in this case, what is the noise? The background color of the image, which is basically when you click from a phone, this that was a white paper. Okay, and that white paper looks bluish, and Tesseract tries to read that data. If you remember from the Tesseract website, this is pure white in the background. So what can we do? We can actually convert the image to grayscale. Okay, the image that we are uploading, we can convert that to a grayscale image. So if we convert it to a grayscale image, then it will focus, like, when you take a text and you kind of xerox it, uh, color from a colored image, you xerox it and you get this grayscale output. It focuses more on the words and less on the background. The background becomes more white. So I hope that makes sense. So we are converting this to a grayscale image. We will also, whatever the converted image is, we will also show that on screen. So you don't have to worry about, oh, I don't know what it looks like. We will also show the converted image on the screen, uh, the grayscaled image. And let's see after that conversion, let's see if the output improves. Okay. And I'm wishing that it does. I hope it does. So, okay. So what's the first step? We are going to first create in the v2. Okay, I'm making all the changes in OCR reader v2.jsx. So in the v2.jsx, let's create a gray scale image, comma set gray scale image. Okay, and use a state variable, use state, initial state is null. Okay, so we have created a variable grayscale image set grayscale image, and the initial state is null, so there is no image as such. There will be no changes in the handle image change, that will remain as is. So as you can now guess, most of the changes are going to be inside the const process image. Okay, now what are the changes in the process image? Let's check that out. So, well, process image will do bunch of things. What I'm going to do is I'm going to kind of remove this bit that we have written, the tesseract.recognize bit that we have written. Uh, we will need to rewrite it. Okay, we will need to kind of do it like do the tesseract thing again, but we'll come back to it later. So let's create a variable. I'm going to call it const img, or let's say my img equals to new image. It's a this new image, it's like a HTML element. Okay, and then I am going to take this variable my image. So my img dot, it has the access to source, say the address or the URL of the media resource. So the way you do img src equals to this, that's what actually we are doing in JavaScript. Okay, instead of doing it in HTML here, the way we do it in HTML, we are doing exactly the same thing in JavaScript. So I'm going to set the source to the image data that is coming as the variable here. So the source of the image has been set to image data. Now, this is going to be a asynchronous operation, or a asynchronous function, which means that it is going to take time, or let's say it's going to run in the background in a way. Okay, what like to simply explain the asynchronous function, what it does is it takes time to give the output. But JavaScript, we need to tell JavaScript to wait to get the output. So that is why we are going to use something called as async and await. So first we will do, so my image dot on load. Okay, so my image dot on load, we will tell it that this is a async function. Okay, so you will need to wait for the output to come, and once the image has been fully loaded, then you are going to run everything that is inside this function. Okay, so once the image has been fully loaded, we are going to make some changes to the image. So step one, let's create a variable called as original width, and that is going to be equal to my image dot width. So we are not going to change the width of the image. Okay, so we are storing the original width of the image. We are also going to store the original height of the image. Okay, we are going to store these two things. And then the next bit is where we will need the TensorFlow JS library. So first, let's install the library before we begin using it. And let me give you the link to the library. Okay, so this is the link to TensorFlow JS. And if I go in here, let it load. TensorFlow slash TFJS. And to install it, you have to run npm I at the rate TensorFlow slash TFJS. And it contains so many things, like they have good tutorials. The example repository has so many things. It's like it's vast, it's huge. And we are not going to be able to try out everything that they give. So we will use bits and pieces of it in the remaining 3 sessions. No, remaining 2 sessions. This is one of the sessions, right? So let's go over to our shell and let's install this library. So npm I at the rate TensorFlow slash TFJS. I'm also going to stop this from running so that it does not give us too many errors in the background. So I've added that, hit enter and let it install. Also, let me post the command in the chat. If someone is running it locally, someone is trying this project out locally, please run this to install TensorFlow.js. Once done, you can actually check it out in your package.json. Okay, TensorFlow. And yeah, coming back to V2, let me close V1, image upload, index.html, git ignore. Yeah, this should be good enough. Okay, and let me shorten this web view. And I hope everyone has reached till this point. I can wait for um 10 seconds if required, and then we can go ahead. Perfect. I see a yep. I am going to take that as golden as golden. Uh, okay, so we need to import this. Now, the best way to import this library would, of course, be to give it a smaller name. Okay, why? Because TensorFlow JS, writing that would be such a problem. Like Tesseract was still a smaller one. So what I'm going to do is I'm going to do something like a named import, and I'm going to say or rename it. Let's say import star as tf from at the rate TensorFlow slash tfjs. So I'm saying that from this particular library, import all the functionalities that exist, but rename it as tf. So now everywhere in my code, I'm going to use the short form tf, which basically means that I'm going to use the TensorFlow library. Okay, now we are going to convert the image to TensorFlow.js tensor. Now this is very interesting. What is a tensor? Uh, Let me come back on screen for this because I think then I would be able to explain it much better. Where is the screen? Yep. And okay, I'm back on screen. So what is a TensorFlow tensor? Now this is very interesting to understand. What is a tensor? It's kind of a fancy name, let's say first. I'll take an example. Imagine you are playing this very famous game called as Tetris. Okay. And what happens is you have these blocks falling, and you kind of align them in a line, right? So now imagine the block that is falling, if it's a square block, uh, each block in that square, so if it's a big square of like four boxes, uh, each block is a number. Okay. Computers understand numbers. That's the least to say. So you can think of these tensors as nothing but a box of numbers. Now the tensors can be uh, like number uh, of anything in a way. So the image data that we are passing it will take that image data, convert it to this block of numbers. Now a block of numbers can be very simple. Example, let's say if you have this in the Tetris, you have this straight standing line, right? Of like five, four or five or six something small squares. So very simple, like a straight line, or very complex. The most complex thing in Tetris, I think, would be that H kind of block. Okay, you have like two here and two here, something like this. You get the idea, right? So that I think is very complex to place anywhere. So your tensors are nothing but this numbers, a matrix of numbers, which could be either simple, one line, one dimension, or could be complex, like a three dimension. Imagine a Tetris where you're also playing like not in just 2D but also in 3D. Okay, so something like that. And so tensor is nothing but a fancy way of saying that, hey, this is a matrix of the numbers. And why are we doing that? Because we take the image data, which is our colored image, which we will give it some values, some numbers. Color is nothing but numbers. So, and then we will then try and reduce the things that are giving it the colors, change it to different numbers. And yeah, that is your the new numbers are the new tensors. Hope that makes kind of some sense. And with that, I'm going to go away from screen, and you can focus on screen again. Okay, so we are going to convert the image to TensorFlow tensors without changing the uh, what do you call the width and the height. Okay, without changing the dimensions. So I'm going to create a new variable called as const tensor, and that is nothing but from our tf dot browser. Okay, what is the tf dot browser? Oh, it does not give you much things, but you can basically see that tf dot browser has this functionality which creates things from image, creates a tf dot tensor from an image. Okay, so tf dot browser dot, it has this from pixels, and I'm going to pass it the image. So I am going to say my image, and let's like just console dot log this tensor. Well, we are calling process image, so I think we should be able to see something if I'm not wrong. So I've clicked on the run button again, and I go back. Let me reload this whole thing. Let me open the inspect element console. Let's upload image. So 1.png uploaded, and this is what comes out. There's something called as strides. There's a shape of the image. There's some data which is currently kind of zero, and yeah, nothing interesting. Data type, it's integer. Okay, 32 bits integer. There's a rank type, no idea. So this is what we see currently from the tensor. Is there any other thing? So there is, like as I said, it's a matrix, so you have bunch of other things that exist on it: cast, seal, clone. So anything that exists on numbers kind of exists on the tensor. Equal, flatten, floor, greater, gather. Okay, too many things. I'm going to remove it for now. But well, that was the use. That was what TensorFlow tensor was doing. Now let's do some processing. So we are going to. I'm going to add a comment here. Sorry, this could be more like a pre-processing. So let's convert the image to a grayscale. And for that, we can create a quick function in a way, variable processed tensor. Okay, and what it does is tf dot tidy. Okay, it executes the provided function. After it's executed, cleans up immediately all the tensors allocated by this. So we are also, so inside this we are going to call create a function to do something, but at the end of it we are going to tidy it up or clean up the memory in a way. So now inside this tf.tidy, let's create a variable. Let's call it gray, and that is going to be, I'm using a let because I'm going to reuse the variable to do some things. So tf.mean, okay, mean of tensor comma 2. So what does the 2 mean? The 2 here means that we are going to take a mean or the average across the color channels or 3 dimensions. You have 3 colors, right? You have RGB color. So we are going to take the average across 2 color channels. Okay, because grayscale is black and white in a way. And then once you have the black and white, you want to, so instead of having RGB 3 colors, let's say, you end up with 2 colors of black and white. uh, this is just for understanding purpose, this is not how it works, but understanding purpose, instead of having 3 colors, we end up with 2 colors. So now I am going to, for the third dimension, I'm going to add -1. So for the third dimension, once we have the average over 2 dimensions, I'm going to add -1 as the third dimension. So you can think of the image as a matrix. So like, let's say if I have to show it, you can think of it as 255 comma 213 comma 6, not 67 should work, yeah. And we are converting this to, like, this is 3 colors, so it's a colored image, but we are converting it to grayscale, let's say. So it is between, uh think of it this way, okay, this is not, but let's say 0 to 55, and the third dimension would be -1. Okay, so you have to kind of ignore the third color. You can, again, I keep using the word, think of it as this way. And now, yeah, okay, and why do we need to add the third dimension? Because sometimes TensorFlow is like, okay, I need the 3 dimensions, but even though I'm not going to work on like converting the values there, it's only -1. But yeah, some of the functions, some of the methods of TensorFlow require 3 dimensions. I had, like, when I was preparing for this session, I tried to do it with 2, and it was giving some weird errors. So I had to like Google it what to do. So tf.div, so we are going to divide every pixel. Uh, so if you remember from my example, I said like, uh, you know, you can think of it as 0 comma 255 comma -1. Now I'm going to divide all the pixels, okay, all the grays, which will be between 0 to 255. uh, so again, let me tell you. Let's say the colors was 255, not 255, 213 comma 145, 245, 215 and 56. We converted this to grayscale, and it kind of became like, for the black it was like, it became something like 0 comma 255 comma minus 1. Now we are going to divide each element in this with 255. Okay, so it would be like, 0 and 1 and minus 1 upon 255. Okay, so whatever this gives you. uh, so why are we going to do that? Because we want the values to be in the range of 0 to 1. Okay, 0 to 1, and this would be again something between 0 to 1, just in minus. So divide all the grays and tf dot scalar, where you tell it kind of to divide it by this. Perfect. And finally, once this is done, let's return gray and format it. Also going to remove this comment. So this is what the processed tensor is doing. We can console dot log this processed tensor, not this processed tensor, comma processed tensor, format it, and let's see what it looks like. Uh, Clean this, reload this whole page, choose file, one.png, open processed tensor. The shape, the size, the strides. Okay. Initially it was int 32, if you remember. Now it's float 32 because, well, some of it is divided by like minus 5, minus 255. Okay, minus 1 upon 255. So some changes, and this is what we end up with. We can kind of also console log the gray. So gray is here. Clean up, reload, one.png. Why did I do that? Because, well, the return is going to be that only. Uh, should have done it here. Probably that would make sense. So I see that the data ID has changed between the step before and the step after. Everything else kind of looks the same to me. So something internal to TensorFlow, which I'm not aware of. Okay, so let's remove our console logs, not really needed. We have processed the tensor, and now let's also, I forgot one thing. If this is async here, this whole function needs to be async. So you have to add the word async here as well. Const process image should be async of image data, and that's how this async will work. Yeah, process tensor, we closed that part. We have returned the gray. So the process tensor is now basically a grayscale image. Now the grayscale image, we will show it on the screen in a while. Don't worry about it. Now let's do what? The tensor would basically be now a 3D matrix in a way, because, well, remember, we converted it from pixels. So we created this tensor which was tf.browser.from pixels. So we need to convert it back to pixels. Okay, so from the image we created the matrix of numbers. Now from the matrix of numbers we need to recreate the image. So let's do that. Yeah, that was the most easiest way to explain it. Like from the numbers we create, sorry, from the image we created the numbers. Now from the numbers we need to create the image. Okay, hopefully that kind of makes sense. Perfect. So const processed image data equals to await tf dot browser dot 2 pixels. Okay, so 2 pixels, what it does is kind of, yeah, returns a promise that resolves when the canvas has been drawn to. uh and that will actually take this processed tensor. Also, if you see here, it gave a description which is no longer to be found. Yeah, if rank 2 draws grayscale, if rank 3 must have depth 1, 3, or 4. So right now ours will have a rank 2, and that's how it will create a grayscale image. Why will it have a rank 2? Because the third parameter is something that we kind of removed, right? Uh, okay, so this is the processed image data, and now let's create a canvas. Okay, why a canvas? Well, that's where we will plot our image. So const canvas equals to, this is Next.js, no, this is plain React, not debugger. Document dot create element. So we are going to create a new element called as canvas. Now for the canvas, the width will be equal to the original width. You remember the original width that we had saved before we went on to kind of destroy the image? That is why we had saved it. So width would be original width. The canvas height would be the original height. And now we have to draw. Like I use the word draw because that's what canvas uses. So once you have created a new canvas with defined width and height, now we need to tell it that we are going to draw a 2D image on this canvas. So const ctx, so this is to tell it that create a or get context of, as you can see, context id is 2D, the identifier of the type of canvas to create. Okay, so we are going to, like, these are the options. You have web gpu type, you have webgl, webgl2, bitmap renderer, or 2D. We are going to go with 2D because we are going to plot a image, a 2D image on the canvas. uh, Even for 3D image, the context could be 2D. So like you have a box which looks from, like, from the side, a cube which looks from the side, but on the image, on the canvas, it would still be 2D. But if you use something like a WebGL, right, or WebGL2, I think that's what allows you to create some 3D elements on the canvas. Okay, so the get context is to create a 2D image or a 2D canvas. Now const image data equals to ctx dot create image data, and the image will be of the original width and original height. So a canvas has a defined size of original width and height of the image. Our image will also have the defined size of original width and height of the image. And then we will do something like image data dot set processed image data. You remember this, from numbers to image, whatever we had done, that's what we are doing here. And this would not be image data, this would be this img data, my bad, like the variable that we had created. That's what we are going to change, img data dot set to process image data. So what are we doing? So we are changing the pixels that we had got, or the image that we had got from here, uh, to like put it in on the canvas, like setting it to the canvas data. And now we have to do something like ctx dot put image data, and you can read all about it on mdn. Oops, just to zoom in. I don't. Okay, something like this. So this is what we will kind of end up with: put image data and ctx image data and the dimensions. Okay, so something similar, but with exactly the image that was created, the grayscale image that was created. So img data, comma 0, comma 0. So the grayscale image that was created, that's what we are plotting or putting on the canvas. What else? I am so sorry I'm not giving you break, but we will reach there very soon. I really want to show you the grayscale output of the image. Uh, so ctx dot put image data and 0, comma 0. Now we will do something like processed image data URL equals to canvas dot to data URL. Now this is where we are, like, we have plotted the image, okay, on the canvas, but it will not be seen, because you remember we have to also show it to the user by using this img tag. So to show it on using that img tag, we are kind of converting the image to base 64 encoding. Okay, and then you remember this variable, the set grayscale image variable. We are going to use that set grayscale image and give it the base 64 encoded image, which is processed image data URL. Okay, we are going to pass it that. And if you remember from our v1, where was that? Here. So from a v1 to the tesseract, we were giving this data, okay, which was basically this process image, sorry, this particular data, yeah. And it was doing something like that. You remember that base 64 encoding? And I was like, it takes the image that is uploaded gets converted to base 64, and that is what is being passed to tesseract. I had also shown you by console log that base 64. So something again similar to that. Okay, we are converting it to a base 64 image, and now we are going to pass it to tesseract. Okay, so now we are going to do something like tesseract dot recognize, and this is exactly the same as what we did before. The only difference would be what data we are passing. So we are going to pass it processed image data URL. We'll tell it, oh, the language is still English. If you don't give it, it's okay. As you can see, it's kind of like undefined. And then we will pass it the options. uh, in the options, what have we done before? We have kind of done this logger thing. So I can copy that, come over and paste it here. So logger, and then dot, like we can do the dot then. So actually I'm going to copy this bit as well. So dot then, and then the end of it, two dots there. Let me format it. Is this, yep, dot then data, then text, and yeah, I think it's everything. And finally, to free up the memory, you don't really need to, but you should, because if you keep on doing it, it kind of blocks your uh, Chrome browser or the browser. Dot dispose. Description says dispose the tf.tensor from memory. Okay, so yeah, that was one hell of a function that we wrote of processing the image, where all we did legit was store the original width and height, then do some pre-processing to convert it to grayscale, pass it to canvas to create the image. Once the image has been created, convert it to a base 64 encoding, save it, then pass it to tesseract to read it. Okay, and now, as promised, we should also show the image. So this was your the image thing was original image, right? So image and the div tag, we can kind of do something like, we can change the styling of the div tag here. So I'm going to remove this max height bit, and I'm going to say the display would be will be flex. I'm going to justify content in center. I am going to add a gap of 10 pixels between this and the grayscale, and from the margin top there is going to be like, it's going to be like 20 pixels down. Okay, format it. So style, so in the div, this is what we have. And then just before the image, let me add another div tag where we add a p tag saying this is the original image. Everything else I would say would remain the same. We can kind of change the max width and max height. So max width would be, let's say, 50%. Let the max height be auto. Okay. This was the image one. So this div should move after the image. Perfect. I think that would make, yep, this should work like charm. And this was the image. I'm going to take this whole thing that I've written, line between like line 61 to line 81. I'm going to copy that, and actually don't really need to after this image. And this is where the div is closing. So after this, actually, I can start, right? I'm going to check grayscale image and then I am going to take this div, okay, from line 70 to line 79. Going to take that and paste that, and I'm going to change the name to grayscale image. The source would now be grayscale image. I can also give it an alt text if required. Let's say grayscale, and I think that should work. There is a problem. I think I'm not closing one of the divs. So grayscale and div tag, p tag, image tag, which auto closes, and this is the closing div. Oh, I think I'm missing this. Yep, a curly bracket. Yep. Now, if I go over to my web view, let me, for the v2, I'm going to choose one.png, open that, and you can see it also shows the grayscaled version. and the extracted text, it still reads the same. So for the V1, that was the V1, and the extracted text read properly. V2, it still reads properly, so not much of a difference. Uh, Let me change one thing, the width of the image. Okay, the max width, that was 50%. If I try to make it 80%, what does happen then? Yeah, I think that should be actually 100. Yep, that's more readable. Now let's try for the 2.png. So 2.png, it was missing the M, and our OCR v2, and like fingers crossed, let's see if it works. It still did not really, right? So it now thinks that there is something here, but it's not reading it properly yet. Okay, and that is very unfortunate. Let me come back on screen. So what is the difference between our v1 and v2? I think the only progress that we have made is the O, which was like small, is now capitalized, as you can see in the image. But this uh, M is still not recognized properly. Okay, so we have still not reached uh, our optimum resolution. Okay, and that is why you're going to create a v3 after this. Okay, but for now I think it's a perfect time to take a 10 minutes break, because well, this was a big journey, right? uh, but there's one really good thing. If you have any colored images, you can now convert it to grayscale using TensorFlow. Okay, so well, if nothing else, you now know how to create a grayscale filter for images. Okay, and that is where I am going to take a quick pause now. It's 15:23, so let's say we can come back at 15:33 or 32, and we'll take it from there. The code, I will send that again in the chat. If you don't see the whole code yet, wait for it to load, or do like refresh once or twice. Uh, Probably open it in incognito or something, so that there's no cache. If there is still cache, you can just do Command Shift R or Control Shift R, and yeah, that is it. So quick 10 minutes break and we'll be back. And before the end of today's session, we will try. Oh yeah, one last thing. So choose file, the 3.png, which was the biggest one, the TensorFlow.js blah blah blah, which was this weird looking text. What happens to that? Grayscale is fine. It's better than the previous one, as you can see. So the Node.js is read as Noda colon JS, which was initially E colon BS. uh, it could not read tensor in the first one. So compared to that, it's still better, right? Tens Elon. Wow, Elon Musk. So tens, let's like there is slight improvement as compared to the previous one, and as compared to v1. Using the TensorFlow, converting it to grayscale has given us a slight edge. Still not perfect, but we will try and reach there. Okay, and if not, then tomorrow's session we'll do completely different project. Okay, like of course it's really not possible to reach there unless you actually get into one of the pre-trained models. Okay, so that is why like in tomorrow's one, we will try and use a pre-trained model if we can, or create a separately a completely new project. I have object detection project in my mind, so We'll reach there. We'll reach there. Okay. Without any further ado, I'll give you a quick break and we'll be back soon. Okay. Thanks, everyone. Any questions, put it in the chat and I'll check it out once I'm back from the break. Cheers. Hello, hello, hello. I'm back. Let me remove the clicker, reduce the volume a bit. Perfect. So good to be back, and we have around 25-ish, 20-ish minutes of session left. So let's get right into it. Let me check if there are any questions. Nope. Yep. We're getting there steadily. We have learned something. It's much better. Uh, yeah. Perfect. So okay, moving on. So let's create the V3. So we have seen what the V2 looks like. We have seen what the V1 looks like. So let's get directly into V3. And I am not saying a V3 would be perfect again, but we can give it a try, right? So I'm going to go like OCR reader v3.jsx. Okay. And now this time I'm going to go against my word and I'm going to legit copy paste this whole thing and paste it here. The things that I need to change is on line number 6, the name of the function, it's v2, need to change it to v3. And at the export default, line 103, that is also going to be v3. Then I'm going to go over to app.jsx and I'm going to copy this div tag from there to this whole v2. I'm going to paste it right below. I'm going to change the color to orange, let's say. And on line 41, instead of v2, this would now be v3, which we need to import, which automatically gets imported here. So let me format this. Let me format v3 and let's go over to our React plus TypeScript. And yeah, v1, v2, v2, this is wrong. This should now the title be v3. So let's go over here somewhere. Yeah, v2, this should be v3. Okay, so v1, v2, v3. v3 currently is exactly the same as v2. Okay, so we have not made any changes as such. uh, Now let's try and make some changes. Now what are the changes that we should make? So we know that the gray scaling of the image helped. Okay, it kind of improved the output. So what else can help better? Okay, so let's look at the output, what it looks like currently. So we know that if we take an image, upload it. Hello from GHW. Hello from GHW, the grayscale image. And it has kind of reduced the background noise in a way. The blue of this whole thing has been removed slash reduced, you could say. And now we have a stark contrast between the background and the foreground. Okay. So what could additionally help us, and I use the word could because it's not exactly like definitely it will help us, but what could additionally help us is to improve this contrast, like make the background more white, make the text more black, so that only the text is what tesseract receives in a way. Okay, other things that could help is kind of uh, again removing the background, like cropping the image itself. So I'm going to do one thing, which would be like, let's try and remove the background. But if we are not able to complete it in today's session, maybe the next bit that I would kind of give you as a homework if I may say that, is that if you could try and you know crop the image in browser itself. So don't upload a cropped image. Crop the image in the browser itself. Okay. So let me go away from screen so that you can focus. And now in V3, we are going to make all the changes in the V3. Okay. So let's focus on V3. Uh, okay. So what are we going to do? So this is fine. Image setting is fine. Text is fine. Grayscale image is fine. Actually, I am going to do one thing. I'm going to rename the grayscale image because it will no longer be grayscale. There will be more processing involved. So always have your variable names say what they are doing. So like have proper variable name. So I'm going to call it actually processed image and set processed image. Okay, and it still be the use state would be null. The handle image change would still work the way it is working. Now let's say for const process image async image data. Now const image equals to new image is fine because that's where we are kind of defining our variable. This is where we are setting the source of it, so that is also fine. This is where we are saying that once the image is loaded, then do bunch of things, setting the original width, the original height. So this is also fine. Creating the tensor, no changes as such. So this is still again fine. From pixels and yeah, I am my image. Now the pre-processing, so const process tensor tf.tidy, that's okay. This is fine. Tf.mean tensor comma 2. Now that's, I think I would say, is still fine. We could do one thing, like, you know, this line of expand dimensions, you can actually kind of add it just after that. So like dot expand dimensions, and you could say like -1 right here. Like this line is not really needed then. Okay, so we have kind of reduced the line, but it does not make any effect. What will make an effect is to adjust the contrast. So I'm going to add something like contrast. Okay, so const contrast factor equals to, now this is a very arbitrary number. I am going to start with 1.5. Okay, and I will like show you what this contrast factor is going to do. Now I'm also going to create another variable called const mean equals to uh, the gray that we had, gray dot mean. Okay, so we are averaging out the grays. Okay, the next would be let contrast, let adjusted contrast, adjusted contrast. Okay, better name. What is this going to do is gray dot sub. Okay, what is the sub? The sub is basically like subtracting. Okay, and we are going to say subtract the mean. Okay, subtract the average of all the grays from each value. So in terms of, let's say, 1 comma 2 comma 3, I am saying that the average would be 7. So 1 plus 2 is 3, 3 plus 3 is 6, 6 divided by 3 is 2. So right, yeah, so now subtract 1 minus 2 from everything. So -1 and then 0 and then 1. Okay, this is what we end up with. So subtract the mean. So the mean for this was, mean was 2. Okay, and then we are subtracting that from the original kind of. Okay, so that's what we are saying. Again, this is kind of to, like, this is not something that I made up from the top of my head. I was checking what is the best way, and one of the solutions that I came across is to subtract this average. So you are kind of scaling everything down to be in the same range. Then you multiply the output. So you got that 1, -1, 0 and 1. You multiply it by the contrast factor, and then again add the average, the mean to it. Okay, So now the new adjusted contrast, as you can see, I used a let. So adjusted contrast would be the old adjusted contrast, which is coming from here, dot, and you have something called as clip by value, which basically, wow, it's not showing the definition, but clip by value basically means that it is going to be in the range. The values should be within a range of 0 comma 1. Okay, something that we did even previously, just by a different method. Okay, and yeah, I think now we can remove the last two lines here, this gray one, and we can just return the adjusted contrast. Okay, now what else? So const processed image data is await tf.browser.2 pixels, where we are basically converting the numbers to image. The canvas should be fine. Actually, like, let me add enter here, and this, let's keep them together. So canvas is creating the canvas, the width and height definition, the context. Uh, this is also fine. Image data dot set to be processed image data is fine. This is still okay. URL is still fine. Now this has changed. This is no longer grayscale. This is called set processed image, right? Set processed image to be processed image data URL, and then tesseract recognize should still be same as before. So yep, and yeah, this should be fine enough. One more change that is needed is, instead of grayscale image here, it is now processed image. Okay, so processed image here, processed image here, and this we will call processed image. And yeah, let me format this. So our v3 is kind of ready. Let's choose a file. I'm going to choose 1.png first, because that's something that we are very sure about. Interesting, it's not showing the text. Did I do something wrong? I don't think so. Set text. Console.log. Is this not working? Okay, let's pick up 1.png, and well, it is a base64 png. So where is the data? Interesting. Okay, let's try it again. I mean, ideally it should have worked. I'm missing something, I'm not sure what. Okay, we can see the difference between the processed image though. uh, the processed image, the background of it has a difference. Okay, previously in v2 it was more grayscale, and now it is like more white. Okay, like not more white, it is exactly white, and the only focus is on the text, right? And why is that happening? That is happening because of this contrast factor. Now you can change the contrast factor. Let's say I keep it to 3.5. From 1.5, I've increased it to 3.5. So now if you see, uh, there's less breaking in the text, right? If you remember, there's like there was more break in the text. I think the best way to see it would be to create a v4, which would be exactly a clone of v3, to see it together. Or actually, like, let's try and remember this. If I give this a contrast factor of 10.5, okay, reload this whole thing, and 1.png, yeah, you can see what's happening in the contrast, right? So 10.5 is too much. What if I give the contrast factor as 0.5? Okay, reload this whole thing, and 1.png, it's white, like it's completely gone. So 0.5 is bad, 10.5 is also bad. What about somewhere between like 5.5? Okay, so the text is not breaking, which is nice, and there's some dots here and there. I don't think that's on my screen as such, or maybe it's on my screen. No, I don't think so. There's these two dots above hello. Uh, okay, and if I give it 2.png, much better, right? So hello from GHW, it's recognizing hello, it's recognizing from, and for the GHW, even from the text, there is a space in between, and it's recognizing exactly that. How cool is it? Okay, I don't know what changed. What did I change in between? But yeah, the extracted text is perfectly working fine. If you remember the 2.png, there was this particular problem, and now it's no longer a problem. So kudos to us. We were able to solve it. Now the final test would be 3.png or even 3a.jpg. They're basically the same image, just the difference is in the format. So now if I give it 3.png, hoping for the best, nope, that doesn't help. Okay. So the contrast is still a problem for the third one. The contrast is better for the second one. Maybe if we increase it to 7.5, do you think that will do the trick? Let's try. I'm not too sure. 3.png, 7.5, and no, not really. Uh, what if I try and do like 8.5? Probably giving it the JPEG one this time. Uh, nope, not really. But we had one win, which was for the 2.png. Okay, this is a bad one for 2.png. What was it? 5.5, I think. That worked perfectly for 2.png, right? So for 2.png, we have kind of reached the optimum level. Okay. I think the problem must be dot. So, okay, you're saying it should not be dot 0.5. Okay, can try that. Let's say if I do 8, okay, just 8, and choose the 3.png, doesn't help, at least like right now. What if I try like 10? Okay, this is like, you remember what happened when we used 10, right? There was like this black ink kind of thrown around. But let's see if that helps you with this one. Not really. Okay, so it's still not reaching there for this big uh, text, which has like, which is my handwriting basically, not really good. uh, like my normal handwriting, I mean. What if I try 20? And it has a mix of this cursive and some capital small, so not really able to recognize it properly. It feels like it was like reaching there. uh, JavaScript has been recognized perfectly. The library not really that well. Librosi is saying it, which is not correct, not true. uh, Try 30. Yeah, let's do it. 30. I'm going to give it 3A, let's say. Okay, I'm still going to give it 3. I think the library died. Oh, no, there we go. Uh, Nope, 30 is bad. I think it should be somewhere around 15, probably. Maybe 15 would give us a better result. Everyone else, I know it's now kind of getting boring, but you get an idea, right? That adjusting the contrast helped us with some stuff, uh, did not help us with other stuff, which is fine. Okay, so let me come back on screen. So that was, we had a small win, which was basically recognizing the second one. Okay, so if I do it 5 and give it 2.png, or I think it was 5.5, one of those, we know that between v2 and v3 we have kind of achieved a proper output. Okay, so v1 very bad, v2 slightly better, it recognized there's something there, v3 much better. Okay, it could recognize the exact text. uh, but we should either build a v4, or I would say, for you all, try it out. What else could be changed? That is something that you could look up. Okay, just Google it, Stack Overflow it. Like if you have to read from text, what can be done? And if you remember, we had given this exact thing to Tesseract. Okay, if you give it this 2.png to Tesseract, it was not good enough. Okay, the O was small, it was missing the M and GHW. That was our V1 basically. But from there, by using TensorFlow, doing some mathematical manipulations, some pixel manipulations, we have reached V3, which is awesome. Okay, I would say it's perfect right now. So yeah, that was the first 2 sessions of machine learning with JavaScript, where we haven't done machine learning yet, but we have used TensorFlow JS, we have used Tesseract JS, and extracted text from image. Okay, which I think is a good win, and it was a good session. So if there are no further questions, I would now end the session. Thank you so much everyone for joining. I'll be back tomorrow, same time as like today's first session. And I hope to see you all there, where we will build some more projects. Okay. So thank you so much everyone for joining. Hope you enjoy GHW and the next upcoming sessions. Thanks all. Love the love in the chat. Okay, so thanks all, bye bye, see you tomorrow, and yep, cheers.